Good afternoon from a wintry Washington, D.C. My name is Diane Ronaldo, and I'm the Executive Director of the OpenRAN Policy Coalition. I'm so pleased you're able to join us today for the third installment of our Coalition Roundtable Series, Innovation in Open Standards for a Diverse and Competitive Market. As you know, we are a member-led organization, and I have to say I was excited when our member companies came to us with the idea of doing a series on technical standards. As a policy organization, we understand that policy created comes from a good place, but good policy comes when you bring stakeholders together. And that's the conversation we've been having for the past eight months now. You want shared expertise, best practices, an understanding of the landscape, a picture of the ecosystem, which will best help you chart a path forward. Today, we're going to be peeling back that policy onion and look at the different sectors. We're going to focus on the different aspects of technical standard setting organizations, what they're doing, and how they're setting the stage for future development and deployment. We would ultimately like that to tie back to the policies that are needed to facilitate our ongoing conversation. We are pleased to say in our short time as an organization, we are currently looking at getting two major pieces of legislation in law. The USA Telecom Act, which includes two new grant programs, one for domestic development and deployment in the United States, and one creates a multilateral fund out of the Department of State that the Secretary will have the ability to help our allies around the world as they build their networks. We are pleased today to have Peter Rasavi, who is going to be our moderator with our esteemed panel. Peter, would you mind coming on and telling us a little bit about your background?
Thanks, Diane. I'm happy to be here today to discuss these important topics. I've been consulting in wireless technology for more than 25 years. Back in 1G, wireless data back then was a dream, and now it's dominating our lives. Networks today are 10,000 times faster, and with 5G, another 100 times faster than that. My work is to analyze the capability of technologies and their evolution, and my projections extend all the way to 2030. An important component of my work is the architecture of these networks, and a very important development in architecture is something called Open Radio Access Networks, OpenRANs, which are a very important development. They leverage virtualization and open interfaces and will provide a wide range of benefits. The purpose of this panel is to explore those benefits and just what OpenRAN is and how it ties in to global standards for wireless technology. At this time, I'd like to bring on my panel, so if they could unmute themselves and turn on their webcams, we'll get started.
Great. I enjoy hearing what you have to say. Thanks again, Peter.
All right, thanks, Diane. All right, I think we have everybody. So I'm happy today to have Anil Bhandari from Altiostar, Lyndon Ong from Sienna, Robert Pepper from Facebook, and Ganesh, Shen Bhagaraman from Radisys. And what I'd like to do is ask each of my panelists to give a brief 2-minute or so opening statement that explains what their organization does, the type of work they're involved in, and how it relates to today's topic, which focuses on OpenRAN. So why don't we begin? I'll just go here, begin with Robert Pepper.
Thank you, Peter, and thanks to Diane and the OpenRAN Policy Coalition for putting this together. I'm on the board of the coalition. It's very exciting. People usually, they want to know, what is Facebook doing as part of a OpenRAN coalition? And my day job is I'm head of global connectivity policy and planning, and a lot of what we do at Facebook that people are not usually familiar with is we're very involved in connectivity solutions, inventing and building new ones, partnering with operators as they deploy them. And we also were one of the founders of something called the Telecom Infra Project, and I'll come back to that maybe later. One of the things that we did, the Telecom Infra Project, was started about 4.5 years ago, and it was designed to examine networking technology broadly, and the focus is, as you mentioned, Peter, this trend towards disaggregated technologies from hardware to software, physical to virtual, and how to make all these things work together. The network operators that we partner with and work with, they want the best breed of technology at each layer of the stack. And with traditional network technology development and deployment, if you buy the radio from somebody, you usually have to buy everything. And so the trend is towards virtualization or software defined and disaggregation. And OpenRAN is probably the most visible, notable of these technologies. And I think it's a really important entry point into the broader discussion of open technologies. Frankly, without the Telecom Infra Project, which, although it started with about 20 companies, 20 to 30 companies, now has over 500, and it's completely global. Many of the OpenRAN Policy Coalition members are members of TIP, and also members of the ORAN Alliance, the standards group, which we'll talk about later. So I'll just use that as an introduction, and then we can come back to some of these issues because it relates to technology development, standards, standardized open interoperable interfaces, because that is what makes OpenRAN work, and that is what makes this move towards a new ecosystem for networking supply chain through disaggregated technologies work. Thank you.
Okay, thanks very much. And Neil, why don't you go next? You need to unmute yourself.
Thank you, Peter. Honored to be here, part of this panel. I'm part of AltioStar. There, I'm responsible for product management. And briefly about AltioStar, so we are a startup. We started in 2012 with the objective of coming out with open disaggregated RAN solution. When we started our company, we looked at the RAN ecosystem and we saw that RAN is one part of the telecom network where all the interfaces are proprietary and hardware is very closely tied to the software. And when we saw where the world is going to go towards 5G, 5G is going to be all about different use cases, which would require innovation, rapid innovation, and that rapid innovation based on the experience of IT world can only happen on the software side. So that's where we strongly felt that we should develop a RAN solution which allows for disaggregation of hardware from software, and it should let open interfaces be used. That would lead to a diverse ecosystem, and that would further lead to innovation and TCO reduction for the operators. So that has been our motivation, and we have been on that path for the last 8 years, and we are getting good traction in the market now.
Okay, we'll go into the details of that shortly. Lyndon, how about you?
Okay, so again, also I'd like to thank Peter and the OpenRAN Coalition for providing this opportunity. So I work for Ciena Corporation, which is known more in the optical world. It's a provider of optical transport systems, but also packet switching and management products to telecom operators and content providers. So we have worked a lot in the past with Facebook on data center interconnection, but we also have a strong market in wireless backhaul solutions and providing software for network inventory and planning and adaptive network control. So we're also active in network dynamic resource optimization and fault recovery. And we've also recently been working on applying artificial intelligence and machine learning techniques to network problems for us, such as optical spectrum optimization and network anomaly detection and repair. I'm in the CTO office in Siena, so we're looking at 5G and 6G as things that will drive operator network requirements and decisions going into the future, and especially understanding management, integration, and integration with transport as being critical things for us for functions such as network slicing and supporting different 5G service types such as ultra low latency services. We're very optimistic and excited about the directions for OpenRAN. RAN has been traditionally pretty closed and had a lot of vertical integration, but we're seeing operators really strongly support a move towards disaggregation and opening up opportunities for additional vendors and technologies. And we're pretty active in the ORAN Alliance on this. And by the way, this is something we see in the optical area as well. We're involved in TIP as well in the optical area, and other organizations like the ONF, where there's been a strong activity looking at disaggregation of optical networks. As for myself personally, I'm not a RAN expert, but I've had extensive experience working in the IETF and ONF on network control and management and software-defined networks. I currently co-chair a working group in the ORAN Alliance, Working Group 6 on orchestration and cloudification, which is responsible for cloud architecture and deployment scenarios or reference designs, and what in ORAN is called the O2 interface for cloud platform management. So I can hopefully provide a view on what's going on there and how ORAN works, especially in the areas of management and control and data plane separation.
Okay, that's fantastic. Ganesh?
Thank you, Peter, and thank you all panelists. It's an honor to be in this panel, and thank you, OpenRAN Policy Coalition, for organizing this event. I head the Integrated Solutions and Ecosystems group here in Redisys. Redisys has been a player in the OpenRAN solution space. We've been providing software solutions, adopting multiple open standards, right from 3GPP, Small Cell Forum, and Oran standards. We've been actively contributing to these forums as well. We are a member of TIP as well, and we've been part of the TIP 4G OpenRAN and 5G OpenRAN programs. And we've been along ONF. We recently joined this project called SDRAN in ONF. We are one of the founding members of the SDRAN project. And with that, we are interacting and working with multiple partners. Our approach is to provide software solutions which are hardware agnostic and with open interfaces. And it allows us to work with a very wide ecosystem set of players here. Happy to be in this.
Okay, Ganesh, just to keep our audience up to date on all the abbreviations, SD-WAN and ONF, what are those?
SDRAN is the software-defined RAN project announced by ONF recently. And
what's ONF?
Okay, Open Networking Foundation.
Okay.
And earlier it was called on.lab, but this is the organization which started visualizing data center-based re-architecture of operators network. That's the origin, and from there it has evolved to touch multiple parts of the network: wireline, core network, and RAN now.
Okay, thank you. Lyndon, what do you see as the main benefits of an OpenRAN approach? I mean, why are we spending so much time doing this? What's the net? What are operators and ultimately consumers going to gain from this?
So I have kind of an ORAN-oriented view, and especially kind of on the management area. But I think from my viewpoint, I kind of see three major objectives in this work. One is disaggregation of the RAN and control functions to allow operators to have greater choice and be able to use additional vendors and select best of breed providers and technology. I also see in the OpenRAN work, encouraging the virtualization of RAN network functions so that RAN network functions can be deployed as virtualized functions and deployed on cloud platforms. And lastly, the introduction of artificial intelligence and machine learning as applications that can be incorporated into the RAN and support greater resource optimization and capabilities using intelligent controller platforms as additional components of the RAN.
Okay, that's great. Ganesh, the key concept of OpenRAN is an architecture that has open interfaces, more modular design, the goal of supporting multiple vendors. I want to just focus on specifications and standards for a moment. What role do specifications and standards play here? And how do these specifications help us shift from a traditional network model that's more like a black box to something that's more open?
Very good. And I think this is sometimes not so well understood, because you can also have a view of why there are so many standards forums for the same RAN technology, right? So I think it's all layered. I believe the base technology for most part of the interoperability as a global standard is still 3GPP, the organization that defines the generations of wireless technology here. And what 3GPP offers is a very, very strong baseline for all the network providers, network infrastructure providers, and the equipment manufacturers, the UE device manufacturers, to apply and conform to the same standard, right? But there are additional, or I would say, opportunities to improve the openness and interoperability on top of 3GPP. And when it comes to the practical aspects of deployment, and when you want to have multi-vendor deployment, right, from an operator point of view, the level of separation from hardware, and these are practical implementation aspects which may not be fully addressed in 3GPP. So forums like Oran Alliance and others, they're trying to address this, right? And from an Oran Alliance point of view, I think the open interfaces is one key thing to achieve multi-vendor interoperability to make this a reality. And the hardware software decoupling is another aspect to allow virtualization of almost all of the RAN network, except some pockets or the aspects like radio side, the radio unit, right? So we're trying to virtualize everything. Then the other pain point usually for the operators is the consistency and uniformity of the management interfaces. And sometimes they tend to be very proprietary based on the vendor, and then it's a problem or a huge problem for the operators to move from one vendor to another vendor in terms of the management systems, because of the variety and the proprietariness about those management interfaces too. And ORAN aims to standardize all of these things, and wherever we need to enhance the level of specification or the level of detail in what is already defined in 3GPP, that is being done through additional standardization in ORAN. So ORAN tries to solve all these problems of interoperability and the practical implementation or deployment challenges too. So that way, as a comprehensive approach, 3GPP plus ORAN, and you can even count a small cell forums effort on FAPI and FAPI standardization also here as another effort towards small cells to standardize everything there. So in a fully standardized world, it's going to be very easy for many of these vendors to interoperate with each other, and gives a lot more choices than to the operators than that existed in the previous generations of the technology.
Okay, thank you. Pepper, what are the specific roles, just digging into standardization a bit more, of the telecom infra project, the OpenRAN project, versus the ORAN Alliance? And then how does 3GPP, that's a third generation partnership project that develops most of the specifications for cellular technology today, how do those three organizations fit together in the development of these specifications and standards?
So yeah, that's actually a great question, because there's oftentimes confusion about that. And the four of us are all, with TIP members. But I think we're also participants in the other groups as well, 3GPP and the ORAN Alliance. So TIP is not a standards body. It really is a technology and architecture development. Actually, it's a TIP foundation, and we all come together in the 11 project groups, the 4 solutions groups. 3GPP, as has been discussed, sets the air interface, the standards for the air interface, right? So this is the sort of the radio standards, and the ORAN Alliance is working on the standards for the interoperability, the interfaces. Software to hardware and hardware to hardware. And in fact, there's an MOU between TIP and the ORAN Alliance, and we all sort of work together. So these are mutually reinforcing, complementary organizations, each having its own role, and those roles actually work together as a sort of a partnering process that's evolved organically over time. And then there's ONF and some of these other organizations as well that fit into this. So it's understanding what the standards, body role is versus the technology development. And even within standards, there's, standards for different types of things. And that's what, so maybe one of my other, my colleagues want to expand on that.
Yeah, I should mention if any panelists, if any of you want to add to the answers, feel free to jump in anytime.
Yeah, I was going to mention also that it's definitely a situation where a lot of organizations are kind of cross members of different bodies, where the different bodies focus on different activities. Certainly with ORAN, there's a lot of awareness that most of the mobile specifications, the standards come out of 3GPP, and so there's a specific effort that's directed towards making sure that the ORAN work keeps aligned with 3GPP, and where there's any extensions, for example, that come up in ORAN, that these get contributed back into 3GPP. So we're trying to do our best there to kind of keep things converging as opposed to diverging.
Okay. And Neil, how, from your experience working with operators, and maybe you could highlight some of your work with specific operators, how does OpenRAN provide more flexibility and visibility for an operator?
So I think as earlier panelists have talked, right, with ORAN now operators have flexibility in choosing their vendors. So operators can now select a hardware vendor, for example, for radio that they have evaluated to be the best vendor available, both technically and commercially, which this kind of flexibility was not available to them in the proprietary ecosystem that has been there till date. Also on the software side now, the panel members, they talked about the work that is happening in ORAN. So with applications or platforms such as RIC, which are being developed, now it is possible for operators to have their own bespoke XApps, algorithms, and this is what is going to now provide the ability to operators to differentiate themselves from one against another, because now they can have their own bespoke algorithms running and doing things like radio resource management or traffic steering and so on. So this is I would say this is the kind of flexibility that OpenRAN solutions are going to bring to the operators.
Ganesh, just to dive into some of the more technical details, a technical approach discussed in OpenRANs is something called the ORAN 7.2 split.
Yeah.
I know that sounds super technical here, but what is the significance of the split and how does that relate to standardization?
Yeah, sure. And if it is one standard or one interface that is so well known about Oran, I think we have to say that it is the 7.2x split. Many times people equate Oran as just 7.2x, and then there's much more happening within Oran Alliance regarding standardization. But this is one of the most popular things adopted, standards adopted from Oran standards. And what it does is basically, this was seen as the most closed interface or tightly coupled interface between the base station and the radio. And right from the underlying transport and the way you manage the base station and the radio, everything was so tightly integrated. You can call it monolithically architected and opaque implementation. So from there, we are evolving to a new standard, call it disaggregation or separating out this functionality with some technical work in that definition of that interface. Basically, the split is still based on the standardization that already happened or the study that was already there in 3GPP. But Oran went to a level of detail to make it a very specific interface definition or a standard, which allows the operators and the equipment manufacturers to suit the implementation as per the deployment needs. When I say that, 7.2x allows two types of radios, category A and category B radios to be developed, and you can move certain functions which were traditionally done in a base station now into the radio. So the radios have a little more functionality than they used to have. And this also optimizes the amount of data that traverses over the front haul. So there is a whole lot of optimization that has gone in terms of the specification. What are the lower level details, bit level details of how you send the data and receive the data. When you're talking about very high throughputs, 5G scale throughputs, the fiber resource is an expensive resource. So how to optimize the data transfer across this link is one key aspect. And there are a lot of profiles defined for interoperability between base station vendors and the radio vendors. So what this has resulted in is actually a new set of players coming into the market and creating radios which are innovative, cost effective, and matching the performance of the closed implementation, right? So this is an area of very high level of activity in terms of new vendors coming in, a lot of interoperability being tested right now in multiple labs and operator trials. So this, I would say, has set off this whole game of disaggregation in the network right from the radio. And we're going to see a lot more revolution happening here, even in the way the radios are getting managed. That's going to change, and that's evolving still in the standardization.
Okay, thank you. A number of you have mentioned disaggregation now, so we should be clear on what that means. And so Pepper, can you talk about that concept of disaggregation and how that translates to ultimately a more diverse ecosystem with a larger number of vendors supplying innovative solutions for wireless networks? I think you're muted.
Thank you. This is one of the most important shifts in the way technology is designed, developed, manufactured, and deployed. I mean, this is a fundamental shift in the supply chain ecosystem, the development ecosystem. In the traditional network, the traditional network was designed end to end. It was all glued together, right? We've sort of talked about that. But as the networks, have developed, especially now that we have radio access networks, there are opportunities for technology development at each layer of the network, right? And even within, for example, the RAN. I mean, we've already been mentioning the separation from the software to the hardware. So one of the trends that we saw probably about a decade ago on the core network was the software-defined network. going from hardware solutions to, software writing on hardware, merchant, mostly, a lot of merchant silicon and so on. There's always hardware someplace, even in software, because it has to run on something. But what we are now seeing is it's no longer just in the core of the network. We're now seeing technology being developed for each layer. And by disaggregation, it's technology for each layer that can interoperate with other technologies from other vendors at that layer through standardized open interoperable interfaces, or across layers. So that if I'm a network operator, I have the ability to use, the best of breed for me in my situation, in my network, at each layer. And what I want to be able to do is have the different modular components work together and work together seamlessly. And that's not been possible in the past when a network was designed end to end. It was all integrated in a way that you couldn't use, different vendors at different layers. And what has evolved now, the result of this movement to disaggregated technology is we've already, as my colleagues have said, new entrants. Ciena's been around a while, which is great. Done amazing work in optical, but now actually is moving into other parts of the stack. Altius, Star, and Radisys are new companies. They could not have existed before to develop, their innovative radio solutions and other solutions in the traditional model. So it's created opportunities for new entrants and innovation at each layer.
Okay, thank you. And Neil,
Yeah.
do you see? Oh, somebody wanted to add to that? Go ahead.
Yeah, I just wanted to add that I think we, Ciena, we've found that there's we're finding a larger community of vendors, both hardware and software, that have been attracted by this move towards disaggregation and the business opportunities that are opening up as potential partners. And one example is we worked on we were interested in doing a demonstration as part of Oran's demonstration effort for Mobile World Congress earlier this year. And we ended up working with Radisys as a partner, also with Wind River, Intel, and AT&T and Dish Network as operators to do a demonstration of an ORAN management environment. And one of the key criteria was that we were both able to support the O1 management interface that's been defined by ORAN, which is basically using 3GPP models and using IETF NetConf Yang as a protocol stack. And we were able to fairly quickly, because we were using these standard interfaces and models, set up a demonstration ORAN environment with the Ciena service management and orchestration and Radisys virtualized RAN network functions running on top of Wind River Kubernetes cloud platforms, and had actually a pretty nice demonstration of what you could do with the standard configuration and management capabilities, which you can see if you go to the ORAN virtual demonstration website on edge orchestration and optimization. So we're finding these standard interfaces to be really helpful towards working with other companies.
All right, and Neil, you wanted to add to that?
Yeah, I just want to, whatever Robert talked about, various benefits. What I just want to add here is that if you look at the current business model, right, even those business models with proprietary RAN architectures are no longer sustainable with the kind of margins some of these companies are having. So again, that's another reason. And if the business model is not sustainable, obviously innovation is going to suffer. So that's another another aspect, that with Open RAN and with this layered architecture, now there are going to be companies who specialize in various layers, like on management domain and on other layers, and these companies are going to bring that agility, lower operational costs, and being able to provide innovation quickly. So that's another side that I wanted to say.
So given all that, Ganesh, do you think that these architectural and technology developments, will they accelerate the speed with which we can deploy 5G?
Of course, yeah. So what we see is just adding a point to the previous discussion, right? What Lynn said about the ease with which multiple companies could quickly integrate and demonstrate. I would say, as a next step, this is creating a level playing field for all companies placed to participate equally and create solutions. And that way, it's a democratization of the RAN space, right? And what we see is there is variety now of players, and this is going to make two things possible: lowering the cost and more innovation to come in, right? And that way, we see there is a greater pace of adoption of, or I would say, right now we are in the stage of many operators in many geographies putting it in the lab trial right now. And earlier, what would have taken a fairly significant exercise to put together this whole budget for this exercise and the complexity involved, understanding the nuances of a proprietary implementation. Now, most operators we see are well aware and quite knowledgeable about the specification. They clearly know what to look for in each of the components they are asking from the vendors. So they also play an active role in selecting the vendors and seeing the results of their trial. And the results are also easily verifiable at each of the interface and node level. And that gives a greater level of confidence. So I would like to say this. So the pace at which the 5G adoption is going to happen, we already are seeing a good sign of it, that it's coming faster than we initially expected, let's say way back in 2018-19. Now in 2020, we see the pace has accelerated a lot, mainly because of the availability of these standards and many vendors adopting these standards. So operators feel very confident about trying this in the lab, and they are making their own rollout plans, which actually are accelerated plans than I'm sure what they had 12 months ago, 18 months ago.
Speaking of schedules, Pepper, do you see OpenRAN as being ready for prime time now? I mean, it sounds like it is, but maybe can you discuss what might be a realistic time frame to think about this? This is a huge restructuring of how these networks operate. So is this something that is going to be turned on across all networks by the end of this year, or is this a multi-year development? What can you give us a roadmap for this transition to this new architecture?
It's already being deployed. Now, you know, it's when you have massive investment in existing networks, 3G and 4G networks, you know, it's a transition as the operators upgrade and replace their equipment as they move to the next generation. What we're seeing is scale deployment already, where there's greenfield. When you're looking at brownfield replacement, the process, it's beginning, and it's going to obviously take some time, but the solutions are there, and it's being deployed. One of the larger announcements about larger projects was, what, 3 or 4 weeks ago, when Vodafone announced that it's going to be using OpenRAN solutions as it migrates from 4G to 5G with its new network across the entire UK, right? So it's the beginning of that process, but that's a big commitment. And so that's the migration to scale. So it's not Peter, maybe a different way to ask the question is not, is it ready? I mean, it is ready and it's, been trialed and it's out there. The question is, at what point are we going to see it move to scale? And we're at the beginning of that journey, but we're seeing it, and we're seeing those kinds of commitments by major operators as well as small operators. And we're also seeing it in greenfield deployments already, because that's not about sort of replacing a migration. And one of the advantages of OpenRAN with visibility to 5G is, especially in some of the emerging markets, is OpenRAN deployment with 4G today with direct line of sight to 5G upgrade. And that's very, very compelling for some of those operators. And again, Anil, Lyndon, Ganesh, you're involved in specific projects.
So if I may add to what Pepper said, OpenRAN solutions are already deployed commercially. As Pepper mentioned, Rakuten is one of the biggest examples of that. And the solutions are ready for prime time. So the solution, OpenRAN solutions now, I mean, I can talk on behalf of Altiostar that advanced techniques like massive MIMO beamforming, etc. So the point I'm making is that OpenRAN can support all the complex use cases, and it is therefore getting deployed at a large scale, both in greenfield as well as in, as Pepper mentioned now, brownfield operators are also moving in that direction.
When you say brownfield, you're referring to legacy networks, 2G, 3G, 4G?
Absolutely.
And is there a difference, Anil, between, say, an urban deployment versus rural? What are the different considerations there, if any?
I mean, I honestly, the way I look at a radio access network is that you are going to have sites, or in any radio access network, you are going to require both 44R kind of radios as well as radios that support advanced techniques like beamforming. So wherever you require capacity, you will probably go for the beamforming kind of solution. And there is, OpenRAN. There's nothing that prevents OpenRAN from supporting this. And as I said, that we are already supporting massive MIMO as well as 44R radios. So
okay.
To summarize, what I'm saying is that OpenRAN can be deployed anywhere, whether it is rural, urban, dense urban. That kind of differentiation is artificial differentiation.
Okay. Lyndon, you used the word cloudification, which I don't think is in my dictionary yet, but I think it's heading there. Can you explain what that is and how that relates to these open interfaces, and maybe touch on Kubernetes, which is a term or the name of a technology that also seems to be associated with these developments?
Sure, Peter. So when I was talking about the demonstration, I mentioned that we used containerized virtual network functions, and we used Kubernetes as a platform for deploying and managing them. We're definitely getting input from the operators that they want to take advantage of cloud technologies and be able to use cloud-native methods to support virtualization of their network functions. So using containers, using sort of de facto open source systems such as Kubernetes. And so what we're doing, for example, in the Oran Working Group 6 cloudification specs that are being developed, so we're working to make sure that these are specifications that are designed to allow people to make use of containers as well as virtual machines, to make use of Kubernetes as well as other platforms. To give kind of flexibility for the operators to deploy the functions on different platforms. And we're getting a lot of participation and input from kind of cloud-centered participants, such as we have a lot of participation in the group from people from Red Hat, from Intel, IBM, VMware, and others that provide input on requirements for cloud-based deployment of RAN functions. So there's a lot of work going on in that area, and we're trying to take advantage of the technology that's being developed in that area.
Okay. Well, as important as technology is, policy is also extremely important. And so, Pepper, what sort of policies do we need from Washington and from governments around the world to allow these technologies to thrive?
So the good news is there are really very few barriers to the deployment, the adoption by operators to be able to use OpenRAN and other disaggregated technologies as they build out, expand, and grow their networks. I think that what's important is that there's a role for government to help facilitate and accelerate this transition. So in different countries, those different policies range from research and development. In fact, Diane at the beginning of this session talked about some of the things that we're working on as the OpenRAN Policy Coalition. Some of the legislative efforts for and legislation that, for example, she referred to in the that's looking at a budget for replacement of existing networks, but also for research and development for international work by governments to work together. I think there's one of the things that we're focused on is educating. There are many government officials who they hear about, 5G is a new shiny thing, and they hear about OpenRAN, but they're not quite sure what it is. And there's a role for industry to bring all of those policymakers up to speed. And one of the things that we've been doing as part of the OpenRAN Policy Coalition, as well as TIP, is educating and working with government officials, policymakers on that. And there's been a remarkable uniformity of support because policymakers want their operators to be able to deploy better technology, more robust technology at lower costs that actually provide wider and better service. There's roles in procurement. Governments are adopting their own technologies for their own networks. And for governments to, in the procurement process, to use OpenRAN solutions, disaggregated technology solutions in their own networks will help facilitate and speed getting, OpenRAN to scale. And this is definitely something that we've done within the OpenRAN Policy Coalition, is identify the basket of activities that governments can do to create incentives, help generate the market, and be supportive of all the companies doing the development and deployment of OpenRAN. As a coalition, we do not support technology mandates. We do not support governments telling network operators what technology they have to use, but rather creating incentives for them to use and adopt new and innovative technologies, such as OpenRAN. And then finally, in some countries, governments play a very important role in facilitating incubators and startups to help create local development of these new technologies. And one of the things that TIP has are what we call community labs, which is really important for testing and verification of the technologies. And in some countries, governments are co-sponsors of those test labs that are bringing together companies to do testing and development in their countries. So it's a wide range of activities that governments are engaged in and can be engaged in that can help accelerate this trend.
Great, thank you. Do any of the other panelists have any policy recommendations or thoughts?
Well, just
Okay.
a note, I guess, from our experiences in Siena. We have a pretty large lab in Canada, and we've been participating in a fairly large effort by the Canadian government called NCORE, which involves setting up a technology corridor and supporting 5G capabilities for researchers and universities to test applications, and participating vendors to test out support for that. So that's been a pretty successful effort, and it's kind of an example of a government effort taking place in Canada in this case.
Okay.
Yeah, I would like to add UK's effort also here. UK government is trying to increase the supplier or vendor diversity, and there's a government-funded project towards that, and they're also quite active in this space.
Okay. So maybe we could broaden the question, which is, I don't know if everybody, I'm sure everybody on this panel knows that, I don't know if the public at large really understands the huge role that 5G is going to play in national economies. It's really going to be the communications foundation for so much of the economy. So maybe a broader question that builds on the previous one is, what are other ways that government can remove barriers to 5G deployment in general? And I'll just throw it out to the panel for anybody who wants to respond.
Well, clearly one of the keys for accelerated 5G deployment is spectrum, and making more spectrum available, both licensed as well as licensed, exempt, or unlicensed. When you take a look at the broad 5G specifications coming out of the early work for the next generation network group as part of 3GPP, we look at the applications for 5G, and it includes long distance, short distance, continuous, bursty, narrowband, broadband, all of the above. And so it's going to be very, very heterogeneous features and uses of what's within the 5G profile that's going to require different characteristics for spectrum in different bands. And without spectrum, none of this is going to happen. And so making sure that spectrum is available, enough spectrum is available for all of these different applications and uses. And then in some countries, we forget, if we're working in the US or we're working in Europe or UK, where there's really flexibility by the operators. When I was ancient history, I was in at the FCC, working on spectrum policy, leading the team that led to managed the first spectrum auctions in the US. The one thing that the US had that other countries at that time were not doing was we provided flexibility. If an operator had spectrum for 2G, they could use it for 3G. They could get more in an auction, or 3G to 4G. Verizon in the US has 4G deployments on spectrum that they received for an analog AMP system way back in the 1980s. That flexibility has allowed the operators to be very innovative and to deploy the latest generations of technology based upon their needs, their customers' needs, and how the market and technology is developed. In some countries, if you have 2G spectrum for 2G, you can't use it for 3G, or 3G, you can't use it for 4G. Spectrum flexibility is an essential policy component to innovation, upgrade, investment, and better broadband, wireless broadband everywhere. So yeah, there's a really important role here, and I'd put spectrum at the top of the list.
Okay, thank you. I have an audience question here which I'd like to address, and I think it's a great one because it says that a lot of the discussion has been operator-centric, but what does OpenRAN really mean to enterprises or business service consumers? How do OpenRANs translates to benefit for enterprises? Let's ask it that way. Anybody want to take a stab at that?
Yeah, I would like to go first, maybe. So I think it applies equally well there in the industrial and private network scenarios. I think we just touched upon the spectrum policy and flexibility. The allocation of spectrum for industrial use or private networks, in some countries it's being thought about and being allocated. And we see that, especially in Europe, this is being adopted. And there are so many enterprises showing interest now to deploy private network for industrial use and various other categories, right? It could be even campus network. So the architectures, that's the beauty of this disaggregated architecture. The architectures, the different deployment options which we have, along with cloudification, lends itself very well for deployment in those self-contained networks. And 3GPP needs standardization all the way up to release 17. They're also, at least now in the standard, you see the clear discussion about the private network in using the terminology called non-public network, how to handle it as a hybrid network, how to handle a private network as a slice of the public network. All these are being discussed and being architected. So I think all of the discussion we've had, I believe they all apply equally well in those private network and industrial use scenarios.
Yeah, I think another related development is something we don't really have time to go into, is called edge computing, and that's having the server capabilities closer to the customer. And as you distribute these data centers to implement OpenRAN, that becomes a very convenient place to also implement edge computing. Anil or Lyndon, is that something either of you have any experience with?
So I can answer that. So Peter, yes, absolutely right. With OpenRAN and with virtualization, now the RAN application is running as a workload on COTS hardware, and with that, it becomes very easy to run on the same hardware, run any other Mac applications. So OpenRAN architecture basically lends itself to automatically support Mac or edge compute kind of use cases.
Okay.
Yeah, I think one of the other things to point out is that there's a lot of work going on kind of standardizing the onboarding of software applications and making it possible to deploy them in platforms, whether they are a metro data center or an edge data center, or even down to a device like the DU, where I think the goal is to make it easier to deploy applications that could be artificial intelligence, machine learning applications, down all the way down to close to the edge.
Good. I had AI as one of my questions, so I'm glad you squeezed that in because we just ran out of time here. I'd like to thank all the panelists today and the OpenRAN Policy Coalition for supporting this event. A recording of this panel discussion will be available and posted to the website within a few days. So thanks everybody, and look forward to future discussions.
Thank you, Peter.
Thank you, Peter.
Thank you, everyone.
Happy holidays, everyone.
Happy holidays.
Happy holidays.